What's up, everybody? This is Jake Burkey with Busted Knuckle Off-Road, and I want to show you our newest product, the King Joint. So what is a King Joint? Well, a King Joint is basically a cross between a ball joint and a kingpin. And kingpins came in all the older model Dana 60s, and the ball joints come in the newer model Dana 60s. And the reason that you need to replace the upper ball joint with a King Joint is because they're wimpy. Whenever you put big off-road tires on your vehicle and you start driving around, you can easily bend them, you can easily break them, and once they break, the entire assembly comes apart, leaving you stranded on the trail. So originally when we started doing this, we were getting rid of the upper ball joint and we were going to a heavy duty style replacement. But over time, what we figured out was that those upper replacements were starting to get wear on them, and we noticed a few things that we could improve on. And this design has a taper in it. And if you look, that taper matches perfectly with this bronze. And what happens is when you tighten down on the top of the bronze, it takes up any slack that can happen throughout years of being in use. This new design offers a couple different advantages, and one of those advantages is sheer strength. If you look at this pin, it is absolutely massive compared to anything else that's out there. The original ball joint that this is replacing is about the size of my pinky, and you can see how much bigger this one is. So because this is huge, you've got your shear taken care of. But the second part that's really good about this particular joint is that this bronze has a little set screw right here in the side. And when you put it into the top of the inner C and you push that set screw together, it expands. And with this installed, it doesn't allow the forces going down to be able to pull that bronze through the top. And what we've seen in the past is that any type of failure has popped the lower ball joint out of its socket and caused the entire assembly to fall apart. And by sharing that load vertically between the upper and lower ball joint, you eliminate that possibility. Picture in your head this steering knuckle installed on the upper and lower ball joint. Okay, so we don't have a King joint right here, right now. It's a ball joint. Whenever you're under load, so your vehicle is sitting on its tires, it's pushing up on both the upper and lower ball joint, and it's taking the ball part of the ball joint and pushing it into the seat. That's normal. When we have an off-road vehicle with big tires on it, every time you hit a bump and the vehicle goes up and down, it takes that lower ball joint seat and starts trying to elongate it. And let's say you have a bad scenario, like you've got a big off-road tire and you hit an undercut or you flip over and you hit something, you can actually take forces and push down on the tire, which can take that lower ball joint and the upper ball joint and pop them out of socket. When that happens, the entire knuckle falls off and you are completely screwed. You're in the woods calling your buddies up trying to get somebody to bring you out on a log. So what we want to do is we want to eliminate the possibility of that lower ball joint being able to pop out of its socket by stopping that force from being just on the lower ball joint. So what the King joint does is this bronze piece goes into the top of the inner C, and with the set screw, it expands the bronze and pinches the bronze. Now that you have this assembly welded to the knuckle, when you try to pull down on this assembly because you've got a big off-road tire and you've taken a big hit and it's pushing down, you are now sharing the load vertically between the seat of the lower ball joint and the top part of this upper kingpin. And that makes this assembly exponentially stronger than anything else available. This taper design also does a really cool thing about the longevity of this entire assembly. Because you have this taper design, this is bronze. And over time, because you're turning back and forth, it's going to wear. It's just going to wear like anything else does. But as it wears, you can actually take this nut here on the top and you can tighten it down and the seats come closer together and it eliminates all that play that you might have. And the other cool thing about it is if you have any play in your lower ball joint, it would take that out as well. So if you have a used project, like you've got an old vehicle that you're going to install these in and you don't have a brand new lower ball joint, when you put this assembly together and you tighten it down, it's going to take all the play out of the system, top and bottom. These are offered for the 1991 to 2004 model Super Duty axles and the 2005 up. We're marketing these as an off-road only part. And the reason is because once you do this, you are eliminating the possibility of adjusting your camber and caster like you would have on that little wimpy ball joint. So this little bronze piece right here, I say little, but it's actually massive compared to the old one, is opened up as big as it can possibly be so that we can make this pin as large as it possibly can be. And in order to adjust your camber and caster, we would have had to have put a small hole in here to allow that to be able to be concentric and move around in a circle. But don't worry, because back in the day, all of the kingpin axles that are out there from the 70s all the way up to 88, all those axles, those straight axles you see in all those off-road vehicles that are running kingpins, you couldn't adjust the camber and caster with the upper anyways. So don't think of this as going in the wrong direction. Think of this as the way it's always been. You know, I really don't know what it would take to break one of these because we've never broken the ones in the past that we were using, and they weren't as large as this. In the off-road industry, we get to see all the failures, and we push these buggies to the limit. And as we're talking today, we produce hundreds and hundreds of axles. And the only place that we've ever seen these axles fail, or these knuckles fail, is right here on the sides of where this strap goes around the upper ball joint. Now, what we're doing with this king joint is we're dropping the size down. We put a really big chamfer right here. And when you press this in and weld the entire top and weld the entire bottom, it strengthens this entire top of the knuckle, making the entire assembly much, much stronger. This is also compatible with our high steer arm package. And if there's anything that you need, we can definitely get it for you. You can get all of this from bustedknuckleoffroad.com. And if you're the type of person who isn't comfortable doing the welding process, you can give us a call and we can send you a knuckle with this already welded in, and you send us your knuckle as a core. To do the installation on this, we definitely want to make sure that we remove the lower ball joint first, because we're going to be doing a lot of welding and we don't want that to smoke all the other components. So you're going to want to get your knuckle completely disassembled, take your unit bearing off, get all your studs out. You're going to want to take your upper and lower ball joints off and basically have it to where it looks like this and it's nice and clean. Now, one thing I will tell you, if you're going to do a high steer arm, we need to make sure that we mill this, because with that king joint sticking up, it gets really close to our mill, and we want to make sure that we can get all that milled out for you. So as you can see, this is a really dirty spot of this knuckle. We're going to be welding it to this area right here and area underneath here, and we want to make sure those areas are clean. So the very first thing that we're going to do is get in here and we're going to clean all this mess out. Now, since I'm an off-roader, I know that most people have a piece of 1 3/4 120 wall tubing laying around. So when I designed this king joint, I designed it so that that would slide right on there and push on that shoulder so you can have an easy installation. Now, it's important to make sure that you install this the correct height. Whenever we designed this, we designed it with a very small shoulder right here, but that was so that we could get the most amount of weld around the top part of this knuckle to make it really strong. So whenever you're installing this, you have to make sure that you're only installing this bottom little piece right here where it's stepped up flush with the top of that knuckle. Now, there's a couple knuckles out there. Some of the aftermarket knuckles have a really large chamfer right there. So what I like to do is I like to get a set of calipers and I'll measure from the top of that little recess spot to the top of the threads, and make sure that whenever it's installed, you are actually the same distance, plus or minus about 20 thousandths of an inch. So I'm going to measure this real quick and see what my distance is. And whenever I do, I'm basically going to just line this up from there out to there. And then I'm going to measure up to the side. And we're sitting at, right there, we're sitting at 3.525. So 3 inches, 525 thousandths. When we install this, we want to make sure that when it's final installed, that from the top of the king joint down to the top of that knuckle where that little ridge is right there is also 3.525 inches tall when it's final installed. Now, if you're going to err, you need to err to the side of this being too tall. It's sticking out of the knuckle too far. And the reason is that this bronze right here, whenever it goes down, is going to snap down inside of the inner C about like this. And when it's all tapped in there nice and neat and you've got it kind of installed, you need a gap between the top part of the inner seat and the bronze, or else you're not going to be able to tighten the bronze down against the taper. So you want to make sure that you have a gap there. And we like to see right about 100 thousandths of a gap. And that makes that assembly so that you can tighten the bronze down later on and take up any type of play. We're going to take our king joint. We're going to stick it inside here like this. We're going to take our piece of 1 3/4 120 wall, stick it there. Then we're going to take this entire ball joint press and we're going to install it on the knuckle. All right, so now that I've got the king joint installed, I want to make sure it's the right height. It can't be too low. So I'm just going to put a flat edge right here and I'm going to measure from that flat edge down to the knuckle, the top part of that knuckle, and make sure that I'm within my specification. I went a little bit too far, so I'm going to take this hammer and just kind of knock this king joint back out a little bit. If you hit it with a hammer and you can't get it to knock out, you may have to use your press. Okay, 535 thousandths, so I'm within my specification. Now we're going to start the welding process. And again, if you're not comfortable with this, you just give us a call and let us do it for you so you know it's going to be done the right way. A lot of people are just going to try to MIG this, and we've done that before in the past, and we've actually seen cracks and failures. So I can tell you how we do it that we've had a lot of success with, and that's with 309 stainless rod, and we TIG weld all of these. Now, there's some other things that you can do that might work. I'm not an expert on every single filler material and every single process. However, this is what we do that works really well. This is a cast knuckle, and because it's cast, it's going to cool at a lot different rate than this really dense hardened chromoly shaft. And in order to get this entire assembly to weld together without cracking, we want to make sure that we're going to preheat this to a certain temperature, hold it there, and then let it cool after the weld. Now, that temperature is about 600 to 700 degrees. So we need to weld this entire assembly while it's 600 degrees, and we need to make sure that we're not just isolating that heat with a small torch right around the weld area. We want this entire knuckle getting to that temperature so that whenever we're welding, it doesn't cool down rapidly. So we're going to take this 309 stainless filler rod, we're going to take our TIG torch, and we're going to fill in this really large gap up here on the top. Now, I made this specifically that you could get as much surface area as possible to strengthen up this little spot right here that we've seen crack before in the past. So you're going to want to weld from the top of this king joint and fan it all the way over to this side edge. And whenever you do the bottom, you're going to want to do the same thing. You're going to want to make really big, wide welds because you're not really worried about penetration as much as you are surface area in this situation. And when you get done with your welding process, you need to make sure that this cools slowly, because if you let it cool fast, you have dissimilar metals that are going to cool at different rates. And if they cool at different rates, it's going to be prone to making the weld crack. So you want to wrap this up in a welding blanket. You can bury it in sand. I've seen people do all sorts of different things. But the goal is to keep this warm for as long as possible. The next step after welding is going to be to put your lower ball joint back in. We just use a regular ball joint press and pull it on in. Now we're going to install the knuckle to the inner seat. So first what we're going to do is we're going to take the knuckle and we're going to slide it through the lower ball joint and king joint holes at the same time. And then we're going to put our nut on to hold it there. So you should be in a situation right now where your lower ball joint is torqued properly and your upper is sitting there loose. We're going to take our bronze and we're going to push it down until you can feel it take up the play. And then you're going to put on this washer. Now, this is a special washer. This is an oil-embedded bronze washer, and it's going to be really slippery between this bronze and this bronze when it's assembled. You're going to take a little bit of grease. You're going to put it between these two components, slide it down. And the goal is to create friction between the nut and this bronze piece and allow the bronze and the washer to spin freely. Now what we're going to do is install the first nut. We're going to take this, we're going to slide it on, And then we're going to torque this to 75 foot-pounds. Now, when we hit our torque, it's going to ensure that the bronze is pushed down the ramp of the king joint, and it's going to swell into the inner C. Now, that is going to lock everything together. We're going to make sure that all the components are fully seated by hitting that 75 foot-pounds first. Then we're going to back this nut off. We're going to put red Loctite in between the threads of the king joint and the threads of this nut. And we're going to come back down, and we're only going to hit 6 foot-pounds at this point, because that is how much preload we want on the assembly. Right there. That's 6. Now, that's all you need, and that's going to ensure that you don't have too much pressure between the bronze and the king joint. The second part about this is your lock nut. You're going to take your lock nut, you're going to come down here on top, you're going to hold your first nut solid, and you're going to torque the second nut with red Loctite again to 150 foot-pounds, locking these two together. When everything is installed properly, what you should see is you should see your upper and your lower nut and your bronze moving at the same time. So you can see all this is pivoting at the same time, and the slippage between the two bronze pieces is what's causing all this to be able to move freely. Now, in this stage, you're going to want to grab this with your hands, and you're going to want to go to full lock both sides and make sure you don't have any hard spots. If you have any really hard spots, something that you have to hit with a hammer, you've got something in there not correct. Now, if you have a couple little small hard spots, that's going to be okay. That's going to work its way out. You're going to go ahead and grease all these components and make sure that everything is Loctited where it's supposed to be, and then we're going to go to the very last step. The very last step of the process that is absolutely essential is that you torque this little nut down right here, this little set screw, to 36 inch-pounds. And what that does is it spreads the upper part of this bronze and keeps it from being able to pull down through the inner C. So you're going to get out your torque wrench, you're going to put in an Allen key, and you're going to torque that down to 36 inch-pounds. You want to make sure that the bronze is actually got a little gap between the bottom of the bronze and the top of the inner C. If you don't have that when everything is fully assembled, you've installed your king joint too low. And because we figured that that would probably happen, we do have some of these bronze pieces that are machined a little bit taller, so we can get you out of that jam. And there you have it, guys. We've got the king joints installed. This is the strongest available option to get rid of those wimpy upper ball joints on your Super Duty axle. This right here is going to last the lifetime of your vehicle. It's going to solve a ton of problems that we see in the off-road industry. It saves your lower ball joints. It allows you to tighten up the plate over time. It's super beefy. I mean, you just can't go wrong. Go to bustedknuckleoffroad.com to get your set.